Alrighty, I had number 18 for my problem, and it was as follows. In the diagram below, drawn not to scale, these two circles are tangent at point 8. B is the center of the larger circle, and CD equals 8, and EF equals 6. What are the radii of the two circles? Alrighty, here's the diagram of the two circles where you could see that EF and CD are the differences between the diameters of the two circles. And for what you do next is have another drawing and then just have it with the triangles for AE and CH, for the points for making two right triangles. And for the from those points there for two triangles between the 2 points on the radius. And what this does is that they're trying to figure out these two unknowns right there. And from that you find out from this that these two make two right triangles, and also that they are similar thanks to the angle theorem all the way back from geometry. And from what that'll do, that'll help us much more easily to find out the radius. There's another way you can do it for the right triangle for using Pythagorean theorem, but that is extremely messy and I do not recommend doing that at all. But it's their two right angles and they're similar and therefore proportional, and this will help us out immensely. For this, that BE, this one right here, that is equal to AE. The difference between BE BS, that is proportional to AE over CH. So right there, and that is also proportional to AB over BH. Over radius of the larger circle over BH. And for that, and for these two are proportional, so the differences between BF and EF, that the differences of the radius are proportional to the difference of the radius of the larger circle, EF over EF. And for what that'll actually set up in, I just sub that back in for BF for the radius of the larger circle. So it's a lot more easier, and this sets us up for a very nice cross product. And that helps us out a lot more. And we're getting with this, and really thankfully for us, you can just subtract out the r squared, and then sets up in even nicer stuff for 36 equals to 4r, and that goes up with the radius of the larger circle is 9. And then from this you just plug the r back in, AD, that is equal to 2r, and from what remember from all the way back in the beginning that for the diameter of the smaller circle is just 8 less than the larger circle. So you can just plug that back in for right there, and it leaves us with the radius of the smaller circle is 5. So I hope this helps out for you. Just being able to set up making right triangles for the different and the two unknowns. That'll set you up for two very similar right triangles, so you can have it all in proportion, and being able to figure out what the radius of the larger circle is, and then being able to plug that in and help you get the radius of the smaller circle. That is how you solve a problem like this.